Electrical work presents significant hazards, demanding strict adherence to safety protocols. The incident serves as a stark reminder of the potential consequences of neglecting safety measures. Firstly, always de-energize circuits before commencing any work. This involves identifying the correct circuit, switching it off at the source, and verifying the absence of voltage using a reliable testing device. Never assume a circuit is dead simply because a switch is in the off position. Lockout-tagout procedures are crucial to prevent accidental re-energization while work is in progress. Secondly, conduct a thorough risk assessment before starting any electrical task. Identify potential hazards such as exposed conductors, damaged insulation, and inadequate grounding. Develop a plan to mitigate these risks, including the use of appropriate personal protective equipment, or PPE, and safe work practices. Thirdly, always use appropriate personal protective equipment. This includes safety glasses, insulated gloves, and appropriate clothing. The type of PPE required will depend on the specific task and potential hazards. Insulated gloves should be regularly inspected for damage, such as cuts, tears, or punctures. Never use damaged or defective PPE. Fourthly, maintain a safe working distance from energized equipment. If it is not possible to de-energize a circuit, maintain a safe distance and use insulated tools. Never reach into or across energized equipment. Fifthly, be aware of the environment in which you are working. Wet or damp conditions can increase the risk of electric shock. Avoid working in wet environments if possible. If it is necessary to work in wet conditions, use appropriate precautions such as ground fault circuit interrupters or GFCIs and insulated mats. Sixthly, never work alone. Having a second person present can provide assistance in case of an emergency. The second person can also serve as a safety observer, watching for potential hazards and ensuring that safe work practices are followed. Seventhly, ensure proper grounding. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electric shock. All electrical equipment should be properly grounded. Test grounding systems regularly to ensure they are functioning properly. Eighthly, use ground fault circuit interrupters or GFCIs. GFCIs are designed to detect small amounts of current leakage and trip the circuit, preventing electric shock. GFCIs should be used in wet locations and in any area where there is a risk of electric shock. Ninthly, inspect tools and equipment regularly. Damaged or defective tools and equipment can create a safety hazard. Inspect tools and equipment before each use and remove any damaged or defective items from service. Tenthly, receive adequate training. Electrical work should only be performed by qualified and trained individuals. Training should cover safe work practices, hazard awareness, and the proper use of PPE. Refresher training should be provided regularly to ensure that workers stay up to date on the latest safety procedures. 11thly, comply with all applicable safety regulations. Electrical work is subject to a variety of safety regulations, such as the National Electrical Code or NEC, and the Occupational Safety and Health Administration or OSHA standards. Comply with all applicable regulations to ensure a safe working environment. 12thly, maintain situational awareness. Constantly assess your surroundings and be aware of potential hazards. Pay attention to what others are doing and communicate effectively to avoid accidents. 13thly, never take shortcuts. Shortcuts can save time, but they can also increase the risk of accidents. Always follow safe work practices, even if it takes a little longer. 14thly, if you are unsure about something, ask. Never hesitate to ask a supervisor or experienced coworker if you have any questions about electrical safety. It is always better to ask a question than to take a risk. 15thly, report any unsafe conditions or hazards. If you see something that you think is unsafe, report it to a supervisor or safety representative. Promptly reporting unsafe conditions can prevent accidents and injuries. 16thly, maintain a clean and organized work area. A cluttered work area can create tripping hazards and make it difficult to access equipment. Keep the work area clean and organized to prevent accidents. 17thly, use the correct tools for the job. Using the wrong tools can damage equipment and increase the risk of injury. Always use the correct tools for the task at hand. 18thly, never modify electrical equipment. Modifying electrical equipment can create a safety hazard. Only qualified personnel should perform modifications to electrical equipment. 19thly, follow lockout-tagout procedures. Lockout-tagout procedures are designed to prevent accidental re-energization of equipment during maintenance or repair. Follow lockout-tagout procedures whenever you are working on electrical equipment. 20thly, be aware of arc flash hazards. Arc flash is a dangerous electrical explosion that can cause serious burns and other injuries. Be aware of arc flash hazards and take appropriate precautions such as wearing arc-rated clothing. 21stly, understand overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from damage caused by overloads and short circuits. Understand how overcurrent protection devices work and how to select the correct size for the circuit. 22ndly, be aware of the dangers of working in confined spaces. Confined spaces can present a variety of hazards, such as lack of oxygen, toxic gases, and electrical hazards. Be aware of the dangers of working in confined spaces and take appropriate precautions. 23rdly, be aware of the dangers of working at heights. Working at heights can increase the risk of falls. Use fall protection equipment, such as harnesses and lanyards, when working at heights. 24thly, be aware of the dangers of working with ladders. Ladders can be unstable and can cause falls. Use ladders safely and follow all safety guidelines. 25thly, be aware of the dangers of working with power tools. Power tools can be dangerous if not used properly. Use power tools safely and follow all safety guidelines. 26thly, be aware of the dangers of working with hand tools. Hand tools can also be dangerous if not used properly. Use hand tools safely and follow all safety guidelines. 27thly, be aware of the dangers of static electricity. Static electricity can ignite flammable materials. Take precautions to prevent static electricity buildup when working with flammable materials. 28thly, be aware of the dangers of electromagnetic fields, or EMFs. EMF are invisible fields of energy that surround electrical equipment. While the long-term effects of EMF are not fully understood, it is prudent to minimize exposure. 29thly, be aware of the dangers of radio frequency, or RF radiation. RF radiation is a form of electromagnetic radiation that can be harmful to humans. Be aware of the dangers of RF radiation and take appropriate precautions. 30thly, be aware of the dangers of microwave radiation. Microwave radiation is a form of electromagnetic radiation that can be harmful to humans. Be aware of the dangers of microwave radiation and take appropriate precautions. 31stly, be aware of the dangers of ionizing radiation. Ionizing radiation is a form of electromagnetic radiation that can be harmful to humans. Be aware of the dangers of ionizing radiation and take appropriate precautions. 32ndly, be aware of the dangers of non-ionizing radiation. Non-ionizing radiation is a form of electromagnetic radiation that can be harmful to humans. Be aware of the dangers of non-ionizing radiation and take appropriate precautions. 33rdly, be aware of the dangers of laser radiation. Laser radiation is a form of electromagnetic radiation that can be harmful to humans. Be aware of the dangers of laser radiation and take appropriate precautions. 34thly, be aware of the dangers of ultraviolet, or UV radiation. UV radiation is a form of electromagnetic radiation that can be harmful to humans. Be aware of the dangers of UV radiation and take appropriate precautions. 35thly, be aware of the dangers of infrared, or radiation. IR radiation is a form of electromagnetic radiation that can be harmful to humans. Be aware of the dangers of IR radiation and take appropriate precautions. 36thly, be aware of the dangers of visible light radiation. Visible light radiation is a form of electromagnetic radiation that can be harmful to humans. Be aware of the dangers of visible light radiation and take appropriate precautions. 37thly, use a voltmeter to verify absence of voltage before working on any electrical circuit. An important step in electrical safety is to always verify that a circuit is de-energized before working on it. This is done using a voltmeter, which measures the voltage between 2 points in a circuit. If the voltmeter reads 0 volts, then the circuit is de-energized. However, it is important to note that a voltmeter can only measure the voltage between 2 points in a circuit. It cannot detect voltage that is present on a single conductor. Therefore, it is important to test all conductors in a circuit to ensure that they are de-energized before working on them. 38thly, use an ammeter to measure current flow in a circuit. An ammeter is a device that measures the current flow in a circuit. It is important to use an ammeter safely, as it can be dangerous if used incorrectly. An ammeter should always be connected in series with the circuit being measured. This means that the ammeter must be placed in the path of the current flow. If the ammeter is connected in parallel with the circuit, it will create a short circuit, which can damage the ammeter and the circuit. 39thly, use an ohmmeter to measure resistance in a circuit. An ohmmeter is a device that measures the resistance in a circuit. It is important to use an ohmmeter safely, as it can be dangerous if used incorrectly. An ohmmeter should never be used on a live circuit. This is because the ohmmeter applies a voltage to the circuit being measured, which can damage the circuit if it is already energized. 40thly, understand electrical drawings and diagrams. Electrical drawings and diagrams are used to represent electrical circuits and systems. It is important to understand electrical drawings and diagrams in order to safely and effectively work on electrical equipment. Electrical drawings and diagrams typically use symbols to represent different electrical components such as resistors, capacitors, and inductors. It is important to learn these symbols in order to understand the drawings and diagrams. 41stly, understand the National Electrical Code, or NEC. The NEC is a set of standards for the safe installation of electrical wiring and equipment in the United States. It is important to understand the NEC in order to safely and effectively work on electrical equipment. The NEC is updated every 3 years, so it is important to stay up to date on the latest changes. 42ndly, know the different types of electrical hazards. There are many different types of electrical hazards, including shock, arc flash, and arc blast. It is important to know the different types of electrical hazards in order to take appropriate precautions. 43rdly, understand the concept of grounding and bonding. Grounding and bonding are important safety measures that help to protect people from electrical shock. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electric shock. Bonding connects all of the metal parts of an electrical system together, which helps to prevent voltage differences between the parts. 44thly, understand the concept of insulation. Insulation is a material that is used to prevent electricity from flowing where it is not supposed to. It is important to use the proper type of insulation for the voltage and current levels in a circuit. Damaged or deteriorated insulation can create a shock hazard. 45thly, understand the concept of overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from damage caused by overloads and short circuits. It is important to use a proper size overcurrent protection device for the circuit. 46thly, understand the different types of wiring methods. There are many different types of wiring methods, such as conduit, cable, and wire. It is important to use the proper wiring method for the application. 47thly, understand the different types of electrical equipment. There are many different types of electrical equipment, such as transformers, motors, and generators. It is important to understand the different types of electrical equipment in order to safely and effectively work on them. 48thly, understand the different types of electrical enclosures. There are many different types of electrical enclosures, such as NEMA 1, NEMA 3R, NEMA 4, and NEMA 4X. It is important to use the proper type of electrical enclosure for the environment. 49thly, understand the different types of electrical boxes. There are many different types of electrical boxes, such as junction boxes, outlet boxes, and switch boxes. It is important to use the proper type of electrical box for the application. 50thly, understand the different types of electrical fittings. There are many different types of electrical fittings, such as connectors, couplings, and lock nuts. It is important to use the proper type of electrical fitting for the application. Electrical safety should be the foremost concern for every electrician.